A very warm and pleasant morning to you, sir. Firstly, let me introduce myself to you. My name is K. Kirti Reddy from CSC B section, currently pursuing BTech second year at Srinivasa Ramanujam Institute of Technology. Today I am here to present a topic from operating systems. My topic is deadlock characterization. Firstly, let me brief out my outline first. My outline consists of introduction, conditions for deadlock, mutual exclusion, deadlock detection, prevention strategies. Now, let us see the introduction to deadlocks. Introduction to deadlock. Deadlock is a situation in computing where two or more processes are unable to proceed because each is waiting for the other to release resources. It significantly affects system performance and can lead to resource wastage. Understanding the deadlock is crucial for designing efficient and reliable system. Deadlock is a situation where two or more processes are unable to proceed because both are ready to process at the same time and it is difficult to select the process which is to be proceeded. It significantly affects system performance, which means by, by selecting a process and letting it to performing to proceed can lead to resource wastage. Understanding deadlocks is crucial for designing efficient and reliable systems. And coming to the definition of deadlock. A deadlock occurs when a set of processes are blocked because each process is holding the resource and waiting for another resource held by other process. It can be visualized as a circular wait condition among processes. Proper identification is essential to implement effective deadlock prevention strategies. Here, the picture gives the clear reference to the deadlock in operating systems. Here, in the picture, we can see that resource 1 is assigned to process 1, whereas process 1 is waiting for resource 2. And resource 2 is assigned to process 2 and process 2 is waiting for resource 1, where the process which are assigned are waiting for the other resources to complete the process. This occurs when set of processes are blocked because each process is holding a resource and waiting for the another resource held by another process. Proper identification is implement effective deadlock prevention strategies. And coming to necessary conditions for deadlock. Four conditions must hold simultaneously for a deadlock to occur: mutual exclusion, hold and wait, no preemption, and circular wait. Each of these conditions contributes to the possibilities of deadlock situation arising. Understanding these conditions helps in developing strategies to avoid deadlocks. So, for understanding the deadlock situations, we need to first learn about mutual exclusion, hold and wait, no preemption, and circular wait. Coming to mutual exclusion. Mutual exclusion refers to the requirement that at least one resource must be held in a non-separable mode. If another process requests that resource, the requesting process must be delayed until the resource is released. This condition is critical in environments where resources cannot be shared. And coming to hold and wait situation. Hold and wait means that process holding resources can request additional resources without releasing their current ones. This condition can lead to processes waiting indefinitely for new resources. It is essential to manage resource allocation to prevent this scenario. In brief, we can say that hold and wait means the processes holding the resources can request additional resources. No preemption. No prevention states that resources cannot be forcibly taken from the processes, holding them until the process voluntarily release the resource. This condition can lead to processes being stuck in the waiting state. Implementing preemption policies can help mitigate deadlock situations. No preemption means that resources cannot be forcefully taken from the process. And coming to circular wait. Circular wait is a condition where a set of processes are waiting for resources in a circular chain. Each process holds in at least one resource needed by the next process in a chain. Breaking this circular chain is crucial to prevent deadlock. We can see circular wait in the previous picture we have observed. Circular wait is a condition where a set of processes are waiting for a resource in a circular chain. And coming to deadlock detection. Deadlock detection involves identifying the presence of deadlocks in a system. Various algorithms exist to analyze the resource allocation graph for the circles indicating deadlocks. Timely detection allows systems to take corrective actions and recover from deadlocks. Here is the pictorial representation for the detection. Single resource instance and multi-resource instance, and this can be identified by using these methods. And coming to deadlock prevention strategies. Deadlock prevention strategies aim to eliminate one or more of the necessary conditions for deadlock. Techniques include resource allocation protocols, such as requiring process to request all resource upfront. Implementing these strategies can help maintain system stability and performance. To prevent deadlocks, there are some protocols such as requiring process and request all resource upfront. And finally, coming to conclusion, characterizing deadlock is essential for understanding how to manage resources in concurrent systems. By identifying the necessary conditions and implementing prevention strategies, we can reduce the risk of deadlocks. Continuous monitoring and analysis are key to maintaining system efficiency and reliability. That's all for my presentation. Thank you.